Okay, good afternoon. This is our lesson for 1-2. I want you to be able to multiply like and unlike bases with exponents, okay? So the bell ringer is what we did in class yesterday, and typically in the video I'm not going to be going over those, but this is our learning target in this video. I can multiply like and unlike bases with exponents. Okay, so when the bases are the same, what that means is I have a 2 here and a 2 here. That means that I'm going to keep the 2, but what kind of exponent am I going to have? Well, 2 to the third power means 2 times 2 times 2. And 2 to the fourth power means 2 times 2 times 2 times 2. And then we have this times dot here that we're going to carry down. Well, once I do that, all this looks like is one big long string of 7 2's. 1, 2, 3, 4, 5, 6, 7. This times dot is no different than that one or that one. So we get 2 to the 7th power. Oh, Miss Andrews, I really don't want to write all these out. Well, good. That's the goal, actually, is for you to recognize, let's see, this had an exponent of 3. This had an exponent of 4. And my answer was 2 to the 7th. So the 3 and the 4 add together to make 7. So the rule is keep the same base and add the exponents. So 3 plus 4 is 7. And we're leaving things in exponential form today. So let's just really quick talk about that, okay? Exponential form would be like 2 to the 5th power. That's exponential form. And if I ask for that form, that's all I want. I do not want you to write it out. I don't want you to type it into the calculator. If I ask for exponential form, that's the answer. That's what it looks like. If I were to write it all out, 5 2's with all the time signs in between. Okay, we call that expanded form. And if I actually answer this, I either type in 2 caret 5 on the calculator, or I multiply this all out in my head, and I get an answer of 32. This is like your final answer, or your evaluated answer. Okay, so today we're focusing on this, our exponential, but we might have a few answers that are in final answer form for your homework, and I will definitely clear that up and explain when you're going to use which during the video. Okay, so if we move on to this next problem, my base is 5, so I'm going to keep the 5. And all I'm really looking at are the exponents, -2 and 5. -2 plus 5, if I 2 degrees below 0, the temperature goes up by 5, I'm at 3. And again, not asking you to do anything more, actually. Now, the next one down has negative bases. So I have a base of -3, but notice it is in parentheses. So I need to keep my answer in parentheses, but then I just go back to my adding exponents. 3 plus 5 is 8. And the whole point of the lesson today is to show you why the shortcut works. Why does it work? So that you can use the shortcut and not have to write -3 8 times. You don't want to do that. Okay, that's what I'm trying to get you to learn, is this shortcut. Okay, so the next one over here is 5 to the 0 power and 5 to the 2 power. 0 plus 2, don't overthink that. It's just 5 squared. Okay, because remember 5 to the 0 power is really 1. So 1 times anything is itself. All right, we've got some negative exponents. And here's where we need to remember negative exponents mean fractions. So I'm going to turn these into fractions. I'm going to do a little work underneath first, and then we'll have a final answer. So 3 to the negative 2 power actually makes it a fraction, 1 over 3 to the positive 2 power. Okay, times 1 over 3 to the first power. But we're still going to apply the same rules. We're going to say 1 over, then the 2 plus the 1, 3 to the third power. Okay, I could have done that a different way. I'm going to demonstrate it down here. I could have just added the bases first, or added the exponents first. So my base is negative 5. 2 plus a negative 5 is a negative 3. And then I could take this answer and give it a positive exponent, 1 over negative 5 to the third power. Because really, negative exponents, they're okay, but they're not your best form of a final answer. The best form of a final answer would not have a negative exponent. Negative base is fine. Negative exponent should really be flipped to a fraction. Okay? So, going on to the next page, fraction bases. Honestly, it doesn't matter what the base is. The bottom line is keep the base. So if the base is 2/3 in parentheses, and then my exponents are 4 and 3. Just add them. 7. Done. Next one. 3/5 is my base. It's a fraction, so leave it in parentheses. Negative 2 plus 6 is 4. Done. All right, what if there's 3 or more bases but they're the same? In other words, this is a 9, this is a 9, this is a 9. They're all 9s. Okay, just keep the 9 as if it was 2 bases, and you just have more exponents to add. So 4 plus 6 is 10, 10 plus 13 is 23. So you're just keeping the same base, and you just have more exponents to add. So I've got 2, 2, 2, and 2. They're all 2s. So 3 plus 5 is 8. 8 plus 7 is 15. 15 plus 9 is 24. Okay? Then we get a little bit trickier. Because what if the bases are not the same? So here, this first problem, the base is 2, and this problem, the base is 3. Well, in this case, there's actually no fun, easy way to make that answer an exponential form. We can't keep the base, because which one would you keep, the 2 or the 3? And we can't multiply the 2 and the 6 because then they don't have the same base. We can't add exponents of things that are not the same. So the only thing we can really do, and we can do this a couple of different ways, the only thing you can really do is on your calculator do 2 caret 3, and that's 8, times 3 caret 4, and that's 81. All right. So what I did was evaluate each exponent separately, and then I can multiply this together, and I get 648. Multiply them together. Now I will say with anything with positive exponents, you could also just type in the problem like this. You could type 2 caret 3 times 3 caret 4 and equals, and get the 648, and kind of skip this step, the 8 and the 81. if it's positive exponents. If it's not positive exponents, when we go to do this one, you're not going to be able to just type this straight up into the calculator. Okay? This one with negative exponents, you're really going to need to evaluate each exponent separately. So 2 to the negative third power really means 1 over 2 to the third. Remember, a negative exponent makes a fraction with a 1 on top, and the exponent becomes positive, times, then we're going to make another fraction with 1 on top and 3 squared positive exponent on the bottom. Okay, and then we're going to treat this like multiply fractions. 1 times 1 is 1. That's not so bad. And then this bottom part, okay, you can evaluate this separately. 2 to the third power is 8. 3 squared is 9. So 2 caret 3 is 8 and 3 caret 2 is 9. And 8 times 9 is 72. Or you could type the whole thing into your calculator and get the 72 in one swoop. 2 caret 3 times 3 caret 2 equals, and that'll give you the 72 typed in all at once. All right, in this next set of problems, some of the bases are the same. For example, there's a 6 here and a 6 here. So we have some bases are the same, but one of them is not. Well, I can simplify this. I can say, well, this is a 6 and this is a 6. So the 5 and the 2 for my exponents can add to make 7. 3 squared, he doesn't have another 3 to add exponents with. So I will just add the exponents of the values I have. Okay, and that's what it says in words up here. Only add the exponents of like bases. So if it's not a like base, I don't add it in. I don't add this 2 to the 7 because these are not like bases. In the next problem, 4 and 4 are like bases. And then, whoops, didn't change color. 6 and 6 are like bases. So my bases are 4 and 6. I can put that in right away. And then 2 plus 5 makes 7. And 3 plus a negative 1 makes 2. All right, I've got a negative 4 as a base here, and I see negative 4 again over here. And I've got 17 as a base here and 17 as a base here. So my two bases are negative 4 and 17 with a times dot in between. And my negative 4 bases are 2 and 3, so that makes 5. Now don't forget to put parentheses around the negative 4. Negative bases get parentheses if they had them to start with. And 5 and 7 make 12. All right, so in class today we really didn't quite get to this in class. I wanted to make sure we got the exit ticket and give you a little homework time, so we didn't quite get to this. All right, but what did this person do wrong? Well, what we learned in class today, let's see, they have 5 to the third times 5 squared, and they have 25. Well, where did 25 come from? Well, they mistakenly multiplied and added the bases. So explain the error made above. Okay. This person multiplied the bases instead of keeping them the same. So what they should have done is kept the 5. So find the correct answer. Kept the 5. Then 3 plus 2 is 5. And then if you wanted to find the correct answer of 5 to the 5th power, I believe it's 5 caret 5. Yep, 3,125. Okay, let's look at a couple homework questions. So first off, I want to point out a couple things in the directions. It says leave your answers in exponential form. That means don't multiply stuff out, except if multiplying with different bases. Here's what I mean by that. So the first one, we have like bases, 5 and 5. I'm going to keep, that means I'm going to have exponential form. I'm going to keep my 5. 3 plus 3 is 6, and I'm done. Number 2 has all 4s for bases. Keep my 4. Then 5 plus 2 is 7, and 7 plus 3 is 10. Done. Okay, but when I scroll down, to number 6, number 6 is not like bases. I have a base of 5 and I have a base of 4. So in that case, I'm going to put in my calculator 5 caret 2 or 5 caret 3, excuse me, and get 125 times, there's no way, I can't do anything with the 5 and the 4. I can't make them a 20. I'm not going to add the 3 and the 2. They're not like bases. I can't apply a shortcut. My only choices are exponential form, which doesn't change anything, or to find a final answer. And that's times 16. Now you could have typed it all into your calculator, 5 caret 3 times, let's make that 4 caret 2, type it all in. Either way, you get an answer of 2,000. And that's an example of where you're putting something in final answer form. Okay, but unless the bases are different, you should have a number with an exponent. Okay, number 21, I'll give you a little hint on. A rectangular field is 2 to the 12th power inches long and 2 to the 8th inches wide. The area of the field in square inches is found by multiplying the length times the width. Give an expression for the area of the field as a power of 2. So here's what I would do. Let's see. I would label my diagram. I'm a big fan of labeling the diagram. 2 to the 12th for the length, 2 to the 8th for the width, and here's the word area. And it even tells you, in case you forgot how to do area, it's multiply length times width. So that means I'm going to do 2 to the 12th power times 2 to the 8th power. And what this wants, give an expression for the area of the field as a power of 2. As a power of 2. That means put 2 as the base. And then I'm going to leave you to figure out on your homework, what should this exponent be right there? Okay, so I'm not going to give you the answer. I want you to figure that part out. All right, thank you for watching the video and have a great day. See you tomorrow.